Hello, folks. Welcome to the Genuinely Interested podcast. My name is Roy Bensby, and I'm your host. And I want to explain a little bit about the podcast before we start the show this week. This podcast is an opportunity for me to speak with some of the most interesting people I know that I can find on the internet. So, either with amazing talents or achievements or just unbelievable life stories or invaluable insights into areas that they have dedicated their lives to studying. I sit down with these amazing individuals from all across the world. Really, I've talked to people from Slovenia to the Czech Republic to Australia to countries in Africa and South America, really just all over the world. And I try to ask them the questions that will hopefully help you extract something valuable or learn something new or just get inspired by. And I do hope that you do get inspired by these talks with some sort of a call to action, maybe change something that you wanted to change for a while, or even just enjoy, detaching from the world for an hour and listening to some great conversations. So whatever it is that you get from this, I do hope that you extract something from it and enjoy the conversations. All these episodes are available on all the major podcast platforms, iTunes, Spotify, Google, and the rest of them. You can also find the episodes on my website, which is roybensv.com. You can find a lot of other information about me there as well, from photos to a little bit more insights into who I am, if you're interested. And, you can always go to social media. I'm on Twitter and Instagram. You can find me there. I'm pretty active on both those platforms, although the only ones I have. And I try to post regularly so you can stay up to date. And also be sure to put your email on the website. I shoot emails out with updates, news, any new current information that I have will be sent via those emails and social media platforms. So yeah, make sure you're in the loop. Thanks for tuning in this week. On this episode, we have Clive Oppenheimer. Clive is a professor of volcanology. His primary research concerns magmatic and volcanic processes, volcanic hazards and volcano monitoring, and the long-range climatic and societal impacts of eruptions. He's also worked with Werner Herzog on, I believe, 3 different documentaries. The last one, Fireball, Visitors from Darker Worlds. They also worked on Into the Inferno and Encounters at the End of the World. I have not seen the new one yet, but I've seen the other 2, and they are absolutely amazing. I believe both are on Netflix. I know Into the Inferno is definitely on Netflix, so you could check that out. The new one is coming out on Apple TV, and maybe with time it'll be on other platforms, but I definitely know it's coming out on Apple TV, so I can't wait for that to be out. I'm super stoked. I saw the trailer. It looks amazing. This episode is mostly volcanoes. So we talked a lot about volcanoes. It's something that I've experienced once, and it was a life-changing experience, and it's something I've always been interested to talk to a specialist, someone who's been in the field a very long time and knows a lot about it, and Clive was the perfect guy to talk to. So if you guys are interested in volcanoes, which you should be, it's an extremely important part of our history, of our future, and how this planet came to be what it is. So I hope you guys enjoy this episode. Without further ado, here is Clive Oppenheimer. Enjoy the episode, guys.
The Genuinely Interested Podcast.
Clive, we're live. How you doing?
Pretty good, thanks. All good, Roy.
Yeah, thanks for coming on the podcast. I know we were supposed to do this last week. You were a little under the weather, so I'm happy to hear that you're feeling much better now.
Yeah, I'd lost my voice. It was peculiar. I felt fine, but I sounded like somewhere between Donald Duck and like I'd just gotten out of bed. Ropey.
Yeah, well, it's better than Donald Trump, so it's better than the other Donald. Yeah, so I wanted to have you on because personally I've always been fascinated with volcanoes. It's just one of the most captivating things I think that exist on this planet. And it's one of those, it's one of those things, it's kind of like fire, like not kind of, it is fire, but you have to kind of like admire it from afar, right? You can't go too close. So what was it that initially interested you in volcanology? How did you get into the field? How long have you been studying? Maybe give us a little bit of a background about it, about you.
Sure. Yeah. I mean, I think probably like most kids, I went through the dinosaur stage and the volcano stage, and I guess unlike most kids, I didn't come out of it again. So in some senses, my career has just felt like the path of least resistance. No, I had no other callings in life, so I ended up working down there, in the underworld.
Yeah.
But when I was about maybe 8 years old, growing up in London, I visited and fell in love with the Geological Museum. And I think what captivated me was just the aesthetic beauty of the specimens, the giant opals and huge gold nuggets and crystals. And I remember they had a radioactive mineral with a Geiger counter on it. So that's where I got the geology bug. And it stayed with me long enough because I ended up studying geology at university. And before I went up to study, I had a year out part of which I spent traveling in Indonesia. So I saw a lot of volcanoes. And I think that sowed a seed of interest in geology that's happening now, as opposed to the ancient earth, and fossils and so on. And certainly in my studies, I was very interested in tectonics and earthquakes. And I think ultimately, a combination of fate and serendipity, or just the way things played out, I ended up doing a PhD on volcanoes. Okay. And that was not initially my intention, because I was really interested in earthquakes. But I ended up studying how we could monitor volcanoes from space using satellites. And so the main part of that project, in a way, was to kind of develop the techniques to use satellite images to measure temperatures in volcanoes. But the exciting part of it was going to volcanoes to test whether the assumptions were valid or not that we had to put into making those estimates.
Okay. And I mean, how extremely difficult is it to study volcanoes?
Well, I think anyone can do it. I mean that in the sense that if you look at the people doing volcanology, they've come from many different backgrounds and training. I have a colleague I work with who did her first degree in English, in medieval English. Mm-hmm. And she's found her way into volcanology. You can find your way in from chemistry or physics or mathematics, obviously geology. So there are a lot of different routes to it, and lots of different ways of practicing it. I mean, you could be at a volcano observatory with a 24/7 operational role to monitor volcanoes, assess their hazards, protect populations, or you might be at the academic end of it, and there it could be that you're doing lab work, maybe simulating volcanic processes at a very small scale in the lab, or studying the rocks under microscopes and other analytical equipment. You might be a computer modeler. Mm-hmm. So you might not go anywhere near a volcano, but you might still be studying volcanic processes. And my version of it is that I base my work around field work. So I do go to active volcanoes. I measure what comes out of them, especially the gas emissions, and try and use that to probe what's going on beneath our feet, where we can't get direct evidence of what's going on.
Yeah, because so if I want to study coral reefs, I go to the Great Barrier Reef or other places where you have corals, and we can study them, and we take samples, and etc. It's not exactly the same, right, with volcanology, in the sense that I can't just go up into a volcano and take whatever I need. It's a very difficult thing to study. unlike maybe some other aspects of science where even like paleontology or whatever it is, you can kind of be right there next to the subject that you're studying. And I think in the documentary, there were just some scenes in the documentary I'm referring to is not Encounters in the End of the World, sorry, Into the Inferno, with Werner Herzog. And there's just some scene that it looks like it's something out of like some science fiction movie, right? It's just this huge inferno, blazing, lava spewing everywhere. Does it feel like you're on Mars or another planet at
It does
times?
sometimes. It does sometimes, yeah. Especially, I'll never forget the first time I went to work on a volcano in Antarctica at Mount Erebus, which is 12,500 feet elevation. And it's when I worked with the US Antarctic program, you fly into McMurdo Station, which is at sea level. And you're in Antarctica, but it's you're around a lot of people, and there's a canteen and dormitory and labs, and the climate's not so extreme.
Mm-hmm.
And it's actually only when you get picked up and dropped off by helicopter up near the top of the mountain, you step out, and the atmosphere is completely different. It's so dry, it's so cold, it's so extreme, and then looking at the landscape, I mean, that does feel like stepping out onto another planet for sure. I think, when I'm working on other volcanoes, I could contrast that with working on, say, Stromboli or Volcano in Italy.
Yeah.
And, in that situation, I probably had my lunch in a very fine pizza restaurant, and then I walk up the volcano and make some measurements. So it's a slightly different kind of experience.
Yeah.
But you need your wits about you when you're working on a volcano, of course. And when I am doing my field studies, I know why I'm there. I know what I need to do, and I need to adapt to what the volcano is up to and what the weather is doing. So you need quite a flexible approach.
Yeah, I mean, I remember in Encounters at the End of the World, I'm pretty sure this was on Erebus, and you're sitting with Werner Herzog, and there's these massive, and you're basically sitting on the edge of the crater, and there's these massive booms. And me as a viewer, I'm flinching, I'm jumping up, and you guys are just deadpan, like you're not even flinching. I mean, is that just from experience, from years of being there? Or, I mean, there's not any part of you that's scared that, some lava is going to be spewed up in the air. And I mean, even if that just grazes you, that could be serious injury.
I can tell you're a Herzog fan. So, I mean, Werner, of course, hasn't spent that much time hanging around volcanoes, and I think I would have run before he would have done.
Yeah.
In terms of what's going on, but it's. I think we have a different threshold as a volcanologist. I guess it's a bit like flying. Some people, they only got to hear a little clunk when the wheels are going up, and it just creates some anxiety. And I've noticed that with friends that I've gone to volcanoes with, again in Italy, vacation. And I'm quite used to feeling the ground vibrate beneath my feet when I'm on a volcano, if it's rumbling away. And if you've never sensed that before, experienced it, then it's quite an experience. It's something that can be quite unsettling for some people. So, I mean, of course, if I saw something pretty threatening going on, I'm going to assess my situation and what my best options are. And if it's to run as fast as possible, I'll do it. But we're not going out. We're not seeking to go and work in risky environments. We're always trying to. We always do risk assessments, and we have a set of plans in place. If things escalate, then we'll stop working as close or whatever makes for safe practice.
You've been all over the world. Do you think you have maybe a different sense or appreciation or perspective on Earth, on life, because also you see how it could be gone in an instant, right? Like if there's some massive eruption, like the whole area around that eruption is just decimated. And I mean, does that perhaps give you a different perspective on life on Earth?
I think being a geologist gives you a different perspective of time and of life. We know in the fossil record there are mass extinctions that are related to massive volcanism or related to asteroid impacts. And of course, we have a different sense of time, I think, being geologists, where, for us, 50,000 years is not that long ago. And I think also for historians, again, when they look at what happens in the contemporary world, whether it's a pandemic or conflict or famine or whatever, for us, it's a big disjuncture in our daily lives. But from a historical perspective, well, that's the human condition.
Yeah.
So yes, I think we do have a certain perspective on it, and it's certainly true that very very large eruptions are very very almost instantaneously transformative events on the environment, the landscape, that might be inundated with ash, and this can persist for years or decades after a very big eruption. Even though the volcanoes quieten down, there'll be a lot of ash that's still being washed down the slopes in the rainy season.
Yeah.
So this can be very disruptive. But the other thing is that very large eruptions can change the global climate. And so an eruption of a volcano in Indonesia can cause crop failures in North America or Europe.
Yeah.
And so this is another way that they can be quite, they're real agents of change at the big scale.
I always wonder when I see massive eruptions, I always wonder if there should be some sort of, I mean, I guess it depends on the government and the country, but there should be maybe a clearing of the area around the active volcanoes. Let's say, I don't know, whatever it is, whatever is possible on the places, maybe 50 kilometers radius, 100-kilometer radius. It almost seems like, I've been living in Connecticut for a bit, and we had all these trees around the house, and there was a storm recently, and a lot of trees fell in a lot of houses. And ever since then, everybody's been clearing the trees, so no more trees fall in houses. And I always, and this is kind of a similar thing. Like if you're next to an active volcano, I mean, it's just a matter of time, right? It could be 10 years, it could be 100 years, but it's going to happen. And it's not like a tree. Like this is not something you want to be anywhere near when it erupts.
Yeah, there are very different kinds of eruptions, and there can be very long timescales between eruptions. So, I mean, to take an example, there was a large eruption of volcano in Chile in 2008, Chaitén. This was not a volcano on anyone's radar as having erupted in the recent geological past. May not have erupted for 10,000 years. So there can be very long repose times in which we live peaceably with volcanoes. I think in a more general sense, it's very easy for us to get fixated on the catastrophe and overlook the fact that societies around the world do live with volcanoes and have lived with volcanoes for many, 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 many generations, and learning to even in some cases adapt to the threat that does arise from time to time.
I mean, how accurate is the instruments that we have to measure eruptions, or I guess the seismic activity that's happening? Are they getting? I'm assuming they're getting better with each year, right?
There are certainly new developments. I'd say just in the last decade or so, there's been a lot of interest in applying UAVs, unmanned aerial vehicles, to go and make measurements close up where you wouldn't really want to go and collect a gas sample, robotics, artificial intelligence. So there are sort of new techniques being brought in, but the mainstay of volcano monitoring is seismology. So measuring the earthquakes, geodesy, measuring the shape of the earth. We can see a volcano inflating prior to eruptions. and
Okay.
measuring the gas emissions, the gas chemistry. And so the tools we have to do that are, they're able to make, seismology can make very, very sensitive measurements, but then you need to use a model to figure out where these earthquakes are occurring and what particular kind of earthquake you're seeing, what's causing it. Gas measurements are a number of problems and challenges in making those accurately. But let's say, we have relatively good tools for monitoring volcanoes. The next question is, what are the signals telling you? And here there's a lot of uncertainty.
Okay.
So, rather like many other kinds of forecasting, we will try and make probabilistic assessments of what these indicators might mean for the future. And even then, your job's not done, because then you've got to be able to communicate that effectively to authorities, civil protection, governments, and the population at large. So, as with other kinds of hazard, your job doesn't end with the science. It ends really with the effective policy making and applying the scientific knowledge you have, acknowledging the uncertainty you have, to try and lead to the best possible outcomes.
Yeah, because essentially there's nothing you can really do. All it is developing technology that at best is going to give us a heads up, right? So that people can evacuate, so that governments can put everything in place, what they need to help the local community or stop, air traffic or whatever is needed. But that's essentially, so is the goal to just predict it as far, into the future as possible, like as early as possible? Sorry.
I think one goal is to make the most reliable predictions, and forecasts, but it's more work in a way is needed to in that interface. It's sometimes called the risk management gap. The science gets you this far, and then here you've got some decision making to do. Do we evacuate 500,000 people from this rumbling volcano, even though we don't know what's going to happen next week?
Yeah.
And in here, this is a big gap to bridge, and I think this is where a lot of work is still very valuable, and part of that is about risk communication, risk perception, the risk tolerance of communities, and we're talking about people now. So this is something that's very variable geographically, from one country to the next, from one region to the next, whether people are familiar with a hazard or not. Is it something they've experienced in their lifetimes, or is this something that, if I turned up somewhere and said, my seismometers are telling me it's time for you to leave, why are they going to believe me unless we put some groundwork in to explain this is our understanding? So we're still going to make mistakes, we're still going to get things wrong, but hopefully slowly we'll make progress in finding better ways to protect people.
Yeah. I like what you said. This is about people at the end of the day. It's kind of like when people talk about climate change or climate related things and they think it's about the environment. It is about the environment, but it's, in a sense, it's about people. If you have desertification and people can't grow crops, that's about people. If you have water rising because sea level rise, that's about people. Like all these things are essentially about people. The earth will, it'll be fine. It's been here way before us and it'll be after us. But that's the thing. I think it's just we're not communicating it in the best way. We have to explain to people that it is actually about people more than it is about the environment.
Yes, and as you say, there's a very close connection between people and the environment. You've only got to look at a map of population density of the world. There's not a whole bunch of people living in the middle of the Sahara Desert. So we are we're constrained by resources, by environmental conditions.
Yeah, and the Sahara that actually used to be and I could get this wrong, but I believe it used to be a forest, right? At some point.
Well, about 5,000 years ago, there was a period known as the African pluvial period, when it was wetter than it is
Okay.
today. But I wouldn't think of that in terms of rainforest. I would think of it more in terms of what is the Sahel today. Mm-hmm. So kind of scrubby vegetation. That was where we have real desert now. So certainly wetter, but not sort of lush tropical forest where we have the middle of the Sahara.
Yeah.
I did some really went on one of the most fascinating bits of field work I've ever done in Chad, in the Sahara, mm-hmm. in the Tibesti Mountains. So this is in the north of Chad, south of Libya. It's a big volcanic province, very, very little studied scientifically because it's been in an area that's not easy to get to. There's been a lot of conflict in that area as well. And one of the reasons I was there was with a team looking for exactly for this evidence of the wetter period in Africa around 5,000 years ago. And these volcanoes had big craters, and there was evidence in the craters that they'd had lakes in them.
Wow!
So this would have been fresh water, would have been very, very important for anyone who was trying to cross the Sahara. This would have been their water tower.
Yeah.
And I found that very, very, very striking. You could see deposits that are laid down in fresh water, and they're about 300 feet above the floor of the crater. And so, you had to kind of imagine that once this was filled with fresh water.
Wow. That's incredible. So you're saying 5,000 years ago?
That's right. Yeah. And this was a time when there were people there.
Yeah.
And actually, it's today it's very, very sparsely populated.
Yeah.
And you don't find Coke cans. It's so the trash you find is 5,000 years old. You find they're not trash, but you find these beautiful rock engravings of a whole bunch of animals that are not there, like elephants, like cattle, and you find a lot of stone tools. You see rock tombs. So it's a testament to when it was wetter there. And maybe people were migrating from the Nile region up to the Mediterranean coast, say up in the north coast of Libya, something like that.
Wow. Yeah. 5,000 years is not a long time for such a drastic change. Like, could we see, and not this is something that I want, but the whole west of the US just seems to be on fire, and obviously climate change is exacerbating this, and you're seeing longer dry seasons. Could this be, I don't know, 1,000 years from now, could, instead of forest and all this lush area that we have there, especially maybe in the Pacific Northwest, which is wetter, could we see the west coast of the US have a completely different landscape due to the wildfires, due to longer dry seasons, in, I don't know, 100, 500, 1,000 years?
Difficult for me to say. I'm not a climatologist, but clearly we're having a profound impact on ecosystems, on the landscape, on vegetation, through deforestation, through the increase in extreme weather events, fires, and so on. So, I'm not good with crystal balls. I'm better at looking back to the past.
Yeah. So I know there's an area called the Ring of Fire, which is over the Pacific Ocean. Why is that area specifically prone to volcanic activity?
So the Pacific Plate, which is nearly all made of ocean plate, ocean crust. When we've got to go back to how ocean is made. It's made at what are called ocean ridges, where volcanoes erupt and new seafloor is created. Mm-hmm. And that makes ocean crust, like basalt rock. And when it gets to 170 million years old, it's cooled down and it's thickened and it's really dense. And it ends up sinking back into the deep earth, what we call subduction zones. Okay. And that's what has happened with the Pacific. Its margins are sinking back into the Earth's interior. And that's associated with big earthquakes. We've seen, very, very big earthquakes, like the Tohoku earthquake in Japan. And it's associated with lots and lots and lots of volcanoes all the way around this Pacific Rim.
Mm-hmm.
So it's part of the plate tectonic scene, and it's it's a very interesting dimension of just how dynamic the Earth's surface is, and how what's going on at the surface is connected with what's going on deep down, which is ultimately it's driven by the fact that Earth is very hot inside, and the mantle, the Earth's largest inner layer, is convecting. There are currents of hot mantle rising up, and then cold currents sinking back down, and it's the way the Earth is losing its heat into space.
Yeah,
but it's the engine of plate tectonics.
This is all fascinating. Essentially, we're all living on a volcanic area that erupted at some point during our history, right? Like the majority of Earth is volcanic activity, right?
Well, not quite. I mean, it's. I guess one way to think about it is we've got these two kinds of plate, two kinds of crust.
Okay.
Ocean crust and continental crust, and the continental crust has been made over geological time by volcanic and magmatic processes.
Mm-hmm.
And when it's made, it's actually quite buoyant. It's very difficult to push it back down into the deep earth again. So it collects at the surface a bit like some froth on a pan of soup you've got on the cooker.
Yeah.
And it just collects there and accumulates over time. So, to some extent, yes, we are living on a planet that has seen an enormous amount of volcanism, but that rock has been recycled in different ways. It's been eroded and formed sediments, and so yes, ultimately the grains of rock that we're living on came out of the Earth's interior at some point deep in time, but they've been through a bunch of processes in the meantime.
Could we see? Because I know in I think it was Japan, there was an underwater volcano that erupted, right, and it formed new landmass somewhere off the coast of Japan, I believe. Could we see bigger ones in the future? Enough to create new countries, new islands in different parts of the world, where there's maybe like more active underwater volcanoes.
Yeah, what's being created is also elsewhere. Stuff is being destroyed when it gets carried down these subduction zones. So if you built a little seamount on the seabed, that might get dragged back down into one of these subduction zones. But yes, I mean, volcanism it can create some new real estate. The example I think of, I worked for a while in the Caribbean on the island of Montserrat, which came back to life in 1995. The volcano there started erupting, Soufriere Hills. It's a pretty small island. It's only a few miles across. And these flows of ash were descending from the summit of the volcano into the sea. And they built out a kind of delta of pumice, which was quite extensive in a way. And I don't know if this is factually correct, but my understanding was that that becomes new crown land for my monarch. Really? So the Queen, if she wants to develop this fantastic real estate, just down slope from the volcano, that she could. But I mean, on the other side of the island, actually, which was where the capital of Montserrat was, Plymouth. The reason it was where it was is because it was relatively flat ground, so it's somewhat easier to develop. And the reason it was relatively flat ground was it was made up of the sediments and deposits from previous eruptions. And that turned out not to be a great place to develop.
Yeah, I would imagine. Do you enjoy the work more where you're out in the field, close to danger potentially, close to the mountains, or do you like to go back to the lab and see the results or test the hypothesis that you had?
I love the field work. I think it's where I feel most alive. Actually, my spirit soars when I'm on a volcano. When I go to Hawaii, it's just it's a joy to be there.
Yeah.
And once I start working, I'm very, very focused on doing what I'm doing. But there's opportunities, in between those intense phases where you feel very privileged to be where you are. But the field work is like the tip of the iceberg. I might go to Hawaii for a week or two of field work. I might go to Antarctica for a bit longer because it's a long way to go and you make the most of it.
Yeah.
But in a week or 2 weeks or 4 weeks, you can collect a lot of data that actually you can then spend months and years analyzing. So that's the buried bit of the iceberg. And actually, I find that very, very fascinating too. I love pulling apart data sets and looking for things that might be hidden in them. And so it's quite obsessive work. Especially if you get a hint that there's some unexpected pattern, then you've really got to figure out if your brain is deceiving you, or if there's really something going on, and you'll need to look at it another way to check if it's an artifact or not. Yeah. And then if you find something that is a real signal, then you get very, very excited and you see some new phenomenon. But still your work's not finished, because then the next question is, what does it mean? Why is the volcano behaving in this way? And that can lead you off to do some more experiments or analyze some rocks in the lab. So it's a long journey, actually. From a couple of weeks field work might end up occupying your mind for the next decade.
That's amazing that you're so entrenched that you would, just try to you would focus on something for years just to find the answer. And most people don't have that type of dedication. So that's pretty amazing.
I think, in some ways, if you're a university-based academic, working on these kinds of phenomena, mm-hmm. You have some luxury to kind of, yes, some things have to be done. You've got a 3-year project and everything's got to be kind of wrapped up, or you're supervising a student, again, who's got they don't want to take forever getting their PhD or their master's. But on the other hand, you can have things that you just sort of keep coming back to. You keep them on the back burner every now and then, have another think. Maybe you've seen some new paper that sparks off an idea of how you might interpret something. So in some ways, you've got that luxury over a career to not completely lose sight of things that maybe you did a long time ago that you might want to come back to one day.
Yeah. Volcanoes are one of those things I don't know, maybe I'm wrong, but I just don't see people putting enough emphasis on. It's, out of all the different science fields that are out there, I just don't hear enough about it. And just as an example, if we talk about volcanoes, just the Yellowstone, the super volcano, right? And again, this is something that could have just been sensationalized by the media, but this is where I heard it. If that erupts, that could pretty much wipe out a good amount of the U.S. And I keep hearing in the media, it's due to erupt. It could erupt at any moment, and they kind of scare us. But that's the only time you really hear about it, when there's a Hollywood type of scenario where everything could be wiped out. That's the only time you hear about a volcano, when it's in a sensationalized type of way. Otherwise, you don't really hear factual, educational information about it. But could that happen? Is it due to erupt, or is that just sensationalized by the news?
My mum always used to say to me, believe none of what you read and only half of what you see. Wise advice.
She's a wise woman.
With Yellowstone, yes, it's had very large eruptions in the past, and we can see that in the rock record. They're not the only eruptions that have happened at Yellowstone. There are far more small eruptions than there are large eruptions.
Yeah.
Whether we look at that globally or whether we look at it on an individual volcano, the very large events tend to be very far apart in time. And the kind of suggestions, you come across this a lot, that Yellowstone's overdue. In some ways, this is based on the fact that there are two very large events, 800,000 and I can't remember when the other one was. Anyway, so it's basically two events, and they're so many years, hundreds of thousands of years apart, and we're now the same since that last one, so it must be due.
Yeah.
This is the wrong way to think about recurrence rates of any phenomenon. You don't kind of take two data points and say, well, okay, it's going to happen. So, I think, Yellowstone is a very, very fabulous place. It is a lot of things going on, a lot of heat flow, a lot of studies have been made of it. It's been imaged. So this is a very, very well monitored system. Yeah. And there are other super volcanoes in the world which are not so well studied. They're very, very, very rare events of that scale. Yes, in the future we can expect another one, but whether that's in 5,000 years or 500,000 years, no one can say. And I think at this stage, because we haven't observed anything like this directly, there would be a question. Let's say Yellowstone is rumbling again. There'd be a question: what kind of signs would you look for to say this is actually going to be a very large event? This is a general question, actually, when a volcano is rumbling. Is it going to come back to life? If it does come back to life, what size of event should we expect?
Yeah, it's a funny thing. We, for the last, 100 years or so, because of technology and science and everything being so advanced, we're almost always trying to suppress nature in one way or form or another, either because we want to gain, some sort of a monetary thing, or for our security, or just because we need it for goods and services. But it's almost like, is there a point where we just have to kind of let nature be nature? And if it needs to wipe out a certain part of the population or of the animals, do we just let it? How much can we? Because, and this is correct thing. We value human life. I wish we would value animal life as well, but we value human life and we want to save it as much as possible. But is there a point where we just have to say, this is it. This is nature, and nature is going to do what nature can do, and there's only so much we as humans can do.
Well, I mean, we're facing that question right now with the coronavirus pandemic. I mean, this question: well, should we just let it run and get herd immunity? Yes, there'll be huge loss of life, or should we intervene? And, more generally, I think, you're right. We're very disconnected from nature. Many of us are very disconnected, not everyone.
Yeah.
If you're a Maasai tribesman, I think you're probably still quite connected with it.
Yeah.
I mean, one of the things that actually drove this, so I've made another film with Werner. We made a film about shooting stars and meteorites. And
that's the new one, right?
Yeah, and I came across an anecdote which I found very, very engrossing. So there was I think it was the Northridge earthquake in LA in '94. Mm-hmm. It was in winter in the middle of the night, and people ran outside their homes, and people were calling the emergency services because there was a strange, weird silvery cloud in the sky, and maybe this was some noxious fumes coming out of the San Andreas Fault or something. And actually, it was just the first time they'd seen the Milky Way. So the earthquake had knocked out the power grid to the Northern Lights. And I think, for us living in cities, we yes, we have a kind of urban ecology.
Yeah.
But we don't even see the stars at night anymore.
Mm-hmm.
And I think that does have quite a profound impact on how society thinks actually about our place in the natural world and our place in the cosmos.
Yeah. If you live in a big city, you're so disconnected. I mean, the fact that you have, I've been living in Connecticut for the past few months, and there's after like 8 p.m., there's basically no lights anywhere outside. And for one, it's beautiful because you can see the stars. But, here in the city, in New York City, there's lights 24/7. So you can go to sleep at 1, 2 p.m. And, on an evolutionary level, I mean, humans, for the most part, when it got dark, right, they just went to sleep. Like no one was staying up till 1 a.m. And there's just so many different things that have happened over time that have changed who we are. And when people say like, "Oh, it's not natural on whatever it is," I always think like nothing's natural about what we're doing right now. We're wearing shoes, we have clothes on, we go to sleep at 2 a.m, we have cell phones. Like nothing is the food that we're eating is GMO'd and it's got all this pesticides on it. Like there's nothing natural about anything that we're currently doing in any way, shape, or form. So, yeah, that's my little rant. What are some current active volcanoes or the most active volcanoes right now that you guys are observing?
Oof, I haven't done much observing for a little while.
As a community.
As a community, that's a good question. Do you know what? I haven't seen a lot of chatter amongst my circles of colleagues about new activity. There was quite a flurry of interest a year plus ago. A volcano called Raikoke up in the North Pacific came to life. Very remote volcano, but there's a whole community of my colleagues sort of watching volcanoes from space. So they'll pick up the emissions, the ash clouds from otherwise quite remote volcanoes that we would know nothing about the eruptions other than maybe a pilot sees something out the window.
Yeah.
But certainly the kind of physical observations we get come from satellite remote sensing. But yeah, I don't know. Maybe the volcanoes are all going off, but or all my colleagues were all in lockdown and just not bothering to go and watch them. I don't know. Yeah, it's been quiet.
It's been quiet. It's good. We don't need anything extra in 2020. There's just every day there's a new headline that let's if we can get over this year, start a fresh 2021. Hopefully everything will be more relaxed. We don't need some massive volcano erupting right now in 2020. That's I think the last thing we need.
Yeah, I did see a calendar which had March. Pandemic and then sort of August was super eruption and then November was asteroid hit and then December was second wave of pandemic.
Yes. There's 2020 and to go back to what you said earlier about COVID, I feel like these lockdowns where it doesn't matter what you feel about them politically, I don't know if they are helpful. I don't know if they're not. I know some countries are not doing them, like Taiwan, and they have a population of 24 million, 535 cases and 7 deaths, and they've done no lockdowns. They were just very smart about how they took action. And I guess the public they listen to the government, they don't cause a fuss, and it's exemplary what they did. And I don't know why other countries are not following suit. Maybe it's political, but I feel like these quarantines, while they potentially could have caused a lot of good by saving people's lives, there's also a lot of downside to it. And one of them is obviously isolation, depression, people not being able to work. So again, it's one of those things I just don't know what the right answer is. But I do hope that after we get through this winter, we can start afresh, and hopefully they'll have a vaccine.
Yeah, I think in some ways there isn't a right answer. These are decisions that have to be made.
Yeah.
Someone has to make a decision. Either maybe the decision is to do nothing, not evacuate the population from the rumbling volcano.
Yeah.
And those decisions have to be made in the face of great uncertainty. So it's easy to go back with hindsight and say, "Oh, that was the wrong call." But in the moment, you have to do the best bona fide effort you can. I think with the information and the models available. Check out the new movie. It comes out 13th November.
Where can people find it?
You need to be on helps if you're on the Apple ecosystem, Apple TV Plus.
It's on Apple Plus? Okay.
Yeah, just a few weeks.
All right, Clive. Well, thanks so much. I had a blast learning a little bit more about volcanoes. And thanks again, man. I really appreciate it.
Not at all. Anytime, right?
All right. Have a good one. Bye-bye.